In this lesson, we want to look at some advanced configuration of infrastructure devices. We're going to start with layer 2, the access switch, and we're going to use an example of our Cisco switch, maybe a 2960, for switch security. So if you take a look at what I put up here, this is some actual configuration on the switch. Notice that we've got port security. So the command switch port security with a question mark shows some of the options we can do here. So this is part of our advanced base configuration where we can actually use the MAC address keyword and we could hard code the actual MAC addresses to the port. So that's kind of an extreme advanced technique, but in a highly controlled environment, maybe these are workstations that just simply don't move around, you could actually hard code the MAC address to the port and then use the maximum keyword where you could say, look, I'm only going to allow 2, maybe 5 maximum MAC addresses to associate to this port. We want to probably do at least 2 to provide for your workstation and your voice over IP phone. But if you're, commonly running virtual machines, maybe on that workstation, you need to accommodate for those MAC addresses as well. And then we have a violation mode we need to set up. By default, if we try to, plug Kali Linux in and use MAC-off to do a flood attack where we're just spoofing a bunch of source MAC addresses and we violate the maximum, for example, well, by default, that port's going to be shut down, which means it's going to be put in the error disabled state. But we have other options as well that aren't quite as brutal, okay? The protect option and the restrict option. At the very least, protect and restrict will not put the port in error disabled state, but it will send SNMP traps and syslog messages, so you will get notification. We can also take a port or 2 ports on a switch and apply what's called switch port protected. This is called PVLAN Lite, okay, or private VLAN Lite. And this can take 2 ports on a switch, and if the 2 ports are both protected, they cannot send frames to each other at layer 2. So this is a way to isolate ports locally on a layer 2 switch from one another by putting in the protected keyword. Now, if I put switch port protected, let's say on, fast Ethernet 01, it can still talk to other ports that are not protected, but it cannot talk to another port that's protected. So we could put servers or departmental servers on those ports and protect them from each other at layer 2 because they don't have to talk to each other. Continuing on, something else you want to do on our switch ports is turn off any auto negotiation, okay? So we want to do no negotiate. We do not want the access port or even a trunk port to allow it to become a trunk port. We want to hard code our trunk ports as trunk ports and hard code our access ports as access ports. So we don't want any negotiation of dynamic trunking protocol or anything else going on, because that's going to open us up to vulnerabilities. Somebody can come in running an exploit kit, and there's a wide variety of tools. And if they can plug in a laptop and they can get access to all of the different VLANs, they can do VLAN hopping, they can do a VLAN double tagging attack. So we want to make sure that we aren't allowing any negotiation to go on. Access ports are access ports, trunk ports are trunk ports, and any unused ports should be shut down and put in their own VLAN. Here we can see something else we have to do in a Cisco environment, because Cisco has a native VLAN for the trunk, which means on a trunk port between the 2 switches, for example, any untagged frames, let's say like CDP or BPDUs or other untagged frames, are going to go in the native VLAN. So we want to make sure that the native VLAN of the trunk between these switches is not VLAN 1, and that they're both the same native VLAN, something besides 1. Okay, in this case, we're going to have both sides of the trunk with native VLAN 999. That's also going to prevent a double tagging attack for us. So, some advanced switch security techniques. And also understanding how your network is going to be zoned and segmented. And there's a wide variety of ways to do this on layer 3 devices and layer 2 devices. At layer 3, we have routers that can create zones or segments based with their interfaces. They can also use virtual routing and forwarding, VRF. There's other methods that we have as well from a service provider standpoint, but at layer 2, we could use private VLANs, okay? And these can be physical, these can be virtual solutions. So for example, as a use case in this diagram, this classic Cisco diagram, we're going to use Cisco Nexus 1000V switches in the data center, which is a comprehensive and extensible architecture with virtual machines, and we can use this for our private or hybrid cloud solution. And in addition to that, we can also introduce private VLANs to get separation from virtual services and servers at layer 2. And private VLANs are an important solution. If you aren't familiar with private VLANs, it's just a way to create logical VLANs within a VLAN. So let's say the data center is a VLAN. We can create logical VLANs within a VLAN, secondary VLANs, without having to readdress our network, readdress our IP version 4 or IP version 6. We don't have to worry about creating new access control list or access control rules. We might want to have a private VLAN for our management VLAN, or maybe the Internet Edge or the DMZ. Okay, and this can also be used in VMware ESX deployments, where you've got virtual servers in a private cloud or a hybrid cloud. So private VLANs are a very powerful feature to get segmentation and zoning at layer 2. Again, closer to the endpoint, very important. Here we see the configuration of a zone on a security router. So this is a Cisco ISR G2 router, and so we're going to create 3 zones: an inside, a public access zone, and an internet zone. Now the PAZ is typically what we would call the DMZ. So this is a 3-zoned firewall. So then we're going to take interfaces, gigabit 01, 02, and so on, and we're going to place these, we're going to assign these to the zone, okay? We'll make them a member of a zone. So 00 is in the internet zone. We're going to put 01 and 02 on the inside zone, and we're going to put 03 in the public access zone in this 3-arm firewall. Then we create a zone pair, and the zone pair is going to allow us to whitelist the traffic sourced in one zone going to another, okay? So we've got 3 zone pairs, the inside to internet, the out to DMZ, or the outside of the internet to the PAZ, and then the outside to the in. And so these zone pairs are where we get the policy applied to them. So this is a common configuration, a base configuration, to create a zone-based policy firewall on a Cisco router. Very important to use a zone-based approach and a policy-based approach and move away from the classic firewall where we're just assigning a bunch of access control lists and rules to interfaces. Okay, this is more next generation. Here we see a Palo Alto next generation firewall, and this by default out of the box uses a zoning process. So to be able to configure a Palo Alto Networks firewall, you're going to have to create zones. And you can see here in the diagram that we have the from zone is trust L3. So it's a trusted layer 3 zone, because your interfaces on a Palo Alto can be a wide variety of different types. It can be a layer 2 interface, a layer 3 interface. It can be a tap interface. It can be a virtual interface. It can be like a transparent firewall interface, right? So you have lots of different options. So this is a trust L3 zone, which means this is on a layer 3 interface, and the 2 zone is the untrust zone. So we can look at this as the 2 zones, or the inside to the outside, or the trusted to the untrusted, or think of it as the private to the public, okay? So some next generation firewalls, and there's others like, Checkpoint and other vendors, they automatically take a zone-based approach. On the adaptive security appliance, we don't use a zone-based approach, okay? We actually have an algorithm that applies rules based on the naming of the interface and the actual security identification. So you have a security level applied to interfaces. So for example here, we would have the inside interface would be security level 100, the highest level, and the outside interface would be security level 0. So by default, on an ASA, traffic from a higher level, security level interface is allowed to go to a lower level interface. And so again, your zone-based approach, your thinking has to be modified when you use something like an ASA, because it doesn't use a zone-based approach. So you have to be flexible based on your environment and the type of devices that you're using in your next generation firewall. Transport security in a router basically means securing layer 3 and 4 of the OSI model. So what we're looking at here is on a router, we're using a policy-based approach to control our connections at layer 3 and 4. So you can see here we've created a parameter map of type inspect, and we're going to use this in our policy for our connection profile. So this router, for example, for its traffic going from the inside to the outside, or in this case, from the outside to the DMZ, we're going to get some transport security. We're going to turn on auditing, so we're going to have the audit trail turned on. We're also going to tweak some of the timers. The TCP fin wait, we're going to change to 30 seconds. The TCP idle time, we're going to change to 7,200 seconds. The TCP SYN wait time, we're going to change to 10 seconds, and we're only going to allow a maximum of 500 sessions. So transport security may mean tightening up some of your TCP and UDP and ICMP flows, in this example, from the outside, from the public internet, to the servers on our DMZ. And we can also do this, of course, on a firewall as well. And the firewall has some built-in thresholds, but we can also tweak those thresholds on an as-needed basis. And here we see, for example, getting transport security level 3 and level 4 on a Palo Alto next-generation firewall, with different categories of applications and different abilities to go in and create subcategories and look at the standard ports that are being used. And we can even look at behaviors beyond just the port that's being used. So we can get conformance to our transport policy based on TCP, UDP, and ICMP. And you can also force these devices to use the RFC behaviors. So any firewall, next generation of firewall, whether it's Cisco or Palo Alto or some other firewall, is going to make sure that the return traffic coming back from the internet, for the most part, is not using illegal combinations of, let's say, TCP flags, okay? So it won't use the SYN and FIN flag. If those are turned on, that'll be blocked, okay? If all the flags are turned on, that'll be blocked. The Christmas tree attack, that'll be blocked. If they're all turned off, that's a null attack. So it does have the ability out of the box to protect your connections from servers that have been compromised on the internet and are sending back illegal RFC type frames and packets. Going beyond some of the basic features, our firewalls can also perform DOS and DDoS protection. This can be called vulnerability protection. And the DDoS protection also, by the way, ties into setting those connection limits, because those can be, by only allowing a maximum number of sessions or a certain number of TCP packets or UDP packets, that's going to prevent against denial of service attacks. But we also have protection against botnets and DDoS attacks, and some of the firewalls, it's built-in feature out of the box. Some, for example, like the ASA, you have to get a feature license for their botnet traffic filtering feature for botnet DDoS attacks. So bottom line, the next generation of firewalls have advanced tools for protection against these types of attacks. And they can work together, by the way, with your intrusion prevention system sensors and other analysis tools, perhaps in the cloud. We talked earlier about network access protection and NAC, so we're kind of returning to this again because in the objectives of the CASP, they also mention this again. So that's one thing that happens sometimes in a course or a particular certification. They have the same objectives show up in different areas, and they did that here. So I just want to make sure that we cover it, but we can also use network protection and network control to enforce policies that's going to protect the transport of TCP, UDP, ICMP, and other traffic, okay? By making sure that our devices have the antivirus tools, the anti-malware tools, that they have the updates and the patches and the fixes and the service packs that they need to have.